Hello guys!
Hello!
It's Sriram.
Ajit.
And Rohit.
Today we are going to learn relation and functions.
Let's learn something about matrix and graph representation of relations.
Let's start. Firstly, we should learn how to write relations. Let's consider x and y, where r be the relation from x to y. So, if for any ij relation r exists, then we are going to write 1 in ith row and jth column. Similarly, if relation does not exist, then we are going to write 0 in ith row and jth column. Here we have write 1 where relation exists, and we have write 0 where relation does not exist. Let's test your brain. Consider x equals to 1, 2, 3, 4, y equals to 1, 2, 3, 4 and relation R where x is greater than y. Then our relation R will be the set of elements where x is greater than y. So for the matrix representation, first remember our rule. So we will make matrix of those elements those exist in our relation. So the required matrix will be Let's talk about properties of relations. First, reflexive. Relation is reflexive if and only if it contains all diagonal elements as one. Here we have an example, set R. It is reflexive because it contains all elements such as 1, 1, 2, 2, 3, 3 and hence in matrix representation it will contain all diagonal elements as 1. Another property, irreflexive. Relation is irreflexive if and only if it contains all diagonal elements as 0. Here set R is irreflexive because it do not contain elements such as 1, 1, 2, 2, 3, 3. In matrix representation, it will contain diagonal elements as 0.
Now, our next property is transitive. Consider our relation contain elements such as 1, 2 and 2, 3. The relation will show transitive property of relation if and only if it also contain elements 1, 3. Now, let's move to the graph representation. Let's consider the example x equal to 1, 2, 3, 4 and y equal to 1, 2, 3, 4 and relation R where x greater than y. Again, our relation R will be given as so graph representation will be.
Now, properties of relation. First, symmetric. Relation is symmetric if there is a return arc exists from second node to the first node. Let's take an example. Here arc goes from first node to the second node and again return to the first node. Next property is antisymmetric. It is opposite to the symmetric property. Relation is antisymmetric if and only if there is no such direct return path exists. In example, arc exists from x to y but not from y to x. It shows antisymmetric property. Next property is reflexive. Relation is reflexive if we have arc starts at node x and ends at node x. This type of arcs are known as loop. If loop exists in the relation, then the relation is reflexive. Next property, transitive. For transitive property, if relation exists from A to B and B to C, then to show transitive property, relation should exist also from A to C.
Created using powtoons.